without further ado, Tal, you're next in line. Just mentioned before, so hopefully you will provide some prevention capabilities. Sorry uh, for that thing. So quickly, let me introduce Tal. He is the smartest guy in the panel and probably in the meetup right now. Tal is the co-founder and CTO of Reco. He has a PhD from the School of Electric Engineering in Tel Aviv University, where his research actually focused on deep learning, computer networks, and cybersecurity. Tal is a graduate of the Talpiot Excellence Program for the non-Israeli Israelis one. It's one of the most luxurious, or probably the most luxurious program I mean, before you start serving in the Israeli army. And usually after that program, you can basically ask to go anywhere you want in the Israeli army. He was also the head of the cybersecurity R&D group with the Israeli Prime Minister's office. In addition to serving as the CTO, Tal is a member of the AI Control Framework Working Group that also Moshe mentioned before. It's part of the CSA. And again, if you are not familiar with the CSA, you should totally check it out. And if you're not familiar with the CSA working groups, and you want to volunteer and participate and share your knowledge with everyone else, please reach out to Moshe or me or basically anyone else in one of the working groups. Tal, the stage is yours.
Thank you, Gidi, very much for the introduction. So, hello, everyone. And today I'm going to talk a little bit of how we can use AI as a protector or defender. Basically, Gidi mentioned, I've been working in the past more than decade on combining or using AI and generative AI for cybersecurity use cases, both in the industry and also in the academy, both as a researcher during my PhD and as a postdoc. A little bit about my research focus, just to show you that there are so many use cases that you can basically leverage AI for them in the cybersecurity space. So I've been using AI both for encrypted internet traffic classification, application identification, and recent research about vulnerability ontology. Basically, how can we predict based on the entire industry if there is a new product that is affected by an existing CVE or vulnerability. Lots of research about IP hijack detection and BGP hijack detection in unsupervised constraint, meaning that we don't have labeled data and we need to be able to detect these attacks in real time, and IoT device labeling, etc. And for this use case and more, I've been using both generative AI, but also AI from different disciplines such as natural language processing, computer vision, and knowledge graph learning, which I personally think that this is by far the most interesting area. So when a lot have been told about the generative AI, and in the past, since October 2022, many people started using it both for data and intelligence collection. A lot has been done from the actor perspective for advanced social engineering attack, for sophisticated and dynamic phishing, and also dynamic malware, meaning that the code is changing dynamically to avoid signature, static signature, etc., and many more. But the Gen AI also open a lot of opportunities for us as defenders, both for data enrichment, being able to discover unknown threat in real time. One example is discovering unknown shadow apps that use a generative AI in real time, phishing, malware detection, and a lot for policy and automation, auto generation. And at the end, it can improve productivity and reduce the risk. If you want to learn more, I really recommend to read this blog by the CEO of the Cloud Security Alliance, Jim Revis. HGPT, please help cybersecurity. And also in Reco, like we have been doing it, for example, in Reco, we have a policy, a no-code policy engine. Behind the scene, we are using a JSON format, and in particular, JSON NATA format. And we have been training Gen AI to be able to basically given a query from a user to generate automatically policy. But besides Gen AI, we both use in Reco generative AI and also regular or classic AI technique for detection and response, detecting risk, user anomaly detection, misalignment between user permissions and the role, kind of advanced capability of SSPM, app discovery and consolidation, and a lot of information about a user and identities. In this particular talk, I'm going to focus on how we can leverage AI to detect SaaS session hijacking. So I'm warning you in front, it's going to be deep about the AI perspective. So a little bit about, so basically SaaS session hijacking, it's usually start from a phishing attack and then followed by a man-in-the-middle attack, allow the attacker to basically bypass login credential and MFA and to gain a direct control of an active session. Using this token, basically, you can access the authorized resources and administrative permission granted to the user. So let's start from the legitimate scenario. Usually in modern enterprises, user connecting or login to application using the identity provider, IDP, it could be Microsoft, Okta, Ping Identity, and more. Basically, this is like the simplest process. The user login to the IDP with credential and ideally with MFA. Then the IDP provide the user and also the application, the specific application authentication token, in which the application can then verify the user based on the session token, and the user from now on can act and log into the specific application. So in order to hijack a session, the attacker will attempt to insert themselves between the user and the IDP to get into the middle of the process. So the trigger usually will be a phishing. It could be via email or via social networks or IAM. In the simple man-in-the-middle scenario, attacker will create, this is a real example from Microsoft, will create a persuasive phishing method to basically trick the user to click on a malicious link. And then the email redirect the user to a seemingly legitimate login screen, which proxies the traffic. And to the user, everything will look and appear normal. Usually, when we talk about a specific link, like in this example, when you click on the Keep My Password button, it points to a URL, and it looked trusted, but then basically the attacker will hijack an actor control domain, usually will be generated using a DGA algorithm, and this will redirect the user to the malicious website. And then will be the session hijacking, and this is like a kind of in a nutshell process. So the user logging into the site provided by the phishing attack. There is a reverse proxy by the attacker that relays the request to the service and intercepting credential. The IDP basically will respond to the man-in-the-middle request. Then it will allow basically the attacker to capture the token, and the man-in-the-middle will relay the response from the IP back to the user, and basically it can now, from now on, use the capture session to authenticate as the user. The result, the attacker intercepts a number of sensitive details, in particular the user IP, credential, and most importantly, the session token. It will allow the attacker to authenticate in the user session without ever needing login credential or MFA token, basically until the session will be expired. So this is another reason why it's important to make sure that there is a short expiration time for session. And this is like a real life example taken from basically from what known from the news about the MGM cyber attack. So basically the attacker scanned LinkedIn for MGM employee, basically looking for a privileged employee that may have access to Okta. The IT helpdesk vendor was targeted by impersonating privileged MGM user and asked basically the IT helpdesk to reset MFA. Then the attacker basically use it to, like we say, to actually do the session hijacking, then log into the Okta. From this point, from Okta admin, he was able to basically remove MFA to other admins and then gain domain admin privilege control, and then decode. In large enterprises, usually the IDP connected between each another through the Okta IDP. You may able to connect to control additional IDP. It's called in Okta they call it org-to-org host. And now the actor find himself have full control on the second IDP, which is basically became a global administrator in the Azure Active Directory. And from this point, it allowed the attacker to encrypt servers, distribute critical application. So the MGM decided to basically shut down a lot of the services to avoid it from being spread, and the rest we all know. So this is basically a real life example. And why is it so hard to detect? So basically, usually is often executed discretely. It's difficult to detect because the attacker reuse a legitimate token and can establish persistent and connected application. And these are the current, I just listed some of the current common detection method. So there is the impossible travel activity, assuming that you are looking on the audit log and seeing like someone that access Okta, for example, from anomalous IP geolocation, irregular time pattern, login from an unrecognized or unmanaged device, and also suspicious mail for activity like forwarding, etc. But the problem with the existing solution is that we are living in an hybrid workforce environment. It means that employees legitimately use devices like and many type of user agent, unmanaged device. They're using both from mobile, desktop, multiple clients you can access from application and from the browser, and different client for the specific application, multiple networks like from the office, from the home, from the organization VPN, for example, through AWS. Also, from the host 2, you give the application permission, legitimate permission to act on your behalf. So you can, if you look at the audit, you can see IPs that belongs to the specific third-party application that connect to your core application, and also working from home for office on the fly and working all the time. So time pattern are not useful anymore or not useful by themselves. So the result is that you try to have like a rule-based policy for each of these heuristic. You will find yourself with a lot of false positive and alert fatigue. So you need to find a way to actually reduce the noise and being able to detect such activities in an efficient way. And this is some example like of this kind of scenario. Let's say that there is a user in the Active Directory, and the user like use, for example, Microsoft 365, and the users can access their email from via Outlook, but they have a third-party app, for example, Superhuman, and they prefer to use Superhuman as the client, so they can use also as a desktop app, and also from the mobile device, from iOS, for example. But they also gave the specific application authorization via host 2 app-to-app connectivity, so you can see there are a lot of traffic and audit originated from the IP that is related to Superhuman, that will enable them to sync the inbox. So these are the legitimate usage that can trigger false session hijacking alerts, and we want to be able to avoid them. So this is a solution that we decided to embrace in Reco, and it is an identity-focused solution. Basically, we want to build a user baseline and organization baseline. How? In a nutshell, 3 steps. The first one is to build a temporal organizational knowledge graph or network graph based on entities and activity from the vast core SaaS application. The second step is identity consolidation. Be able to correlate all the identity with the related accounts, like taking account from all of the different applications and make sure that, okay, all of these belong to the same person. And using AI or graph machine learning models in particular to correlate identity with the activities, IP, location, devices, third parties app, being able to build the baseline and look for major changes over time. For one of the step, which is the identity consolidation, I will give an example. In this particular example is about machine identity or application consolidation. So when you're talking about application in SaaS, there are 2 formal users. First one is human that actually connect to the specific application via IDP or social login. And there is the machine to machine, SaaS to SaaS connectivity using those two. And these are the application that we want to be able to map and also consolidate. A short recap about terminology. Generative AI is basically a type of AI that can produce various types of content, basically generate content like text, image, audio, and synthetic data. Retrieval augmented generation is a specific way to use a generative AI. It's an AI framework that basically enable the LLM, large language model, to retrieve information in real time based on external knowledge. And then the LLM is being able to get this information and do what we also call in-context learning, and basically provide an answer based on this information as well. So this is like example from behind the scene from the graph. We have seen, for example, many type of application that connected to Google, but also many type of application that connect to Microsoft. There are many applications, all of them or most of them have different names, but although that usually they are the same, they belong to the same vendor, they are the same application, and we want to be able to consolidate the identity. So this is the way that we do it in Reco, using, like I say the retrieval augmented generation. So every app instance that we ingest from every basically source that we support, we enrich, then we embrace generative AI to create generic app ID. Like this is internal ID that we use in Reco to combine and consolidate. And we also, in parallel, we also apply similarity search to be able to match the new application to the new app instance to app instances that we already have seen in the past. An example of basically semantic similarity search. So when we talk AI, when we talk LLM, when we talk generative AI, AI basically or deep learning model, they work well with numbers. Like it's much easier to measure distance or similarity using vectors of number. So every word, for example, in computer vision, every image is basically being embedded into a vector, also called embedding. And this vector have meaning, and we aim that this vector will capture internal characteristic, and when we talk about natural language processing, we aim that word or text that have semantic similarity, their vector will also be similar. So basically, we text the enrich app name, we embed using GenAI model to a new space. And this, for example, you can see that application that related to the same application are very close to each other, although, for example, they have like a very different name. For example, Gmail Lightning Sync and Salesforce Connector, both of them are Salesforce applications. So this is one example. And basically, the result is being able to consolidate. For example, in the Zoom example, you can see that even in the specific connector, like Google, there are different names, and we are able to connect all of them. And of course, this is basically the simple case. And this is at the end how it looks in the product. So why is consolidation so important? And in particular, for machine identity and human identities. So the first answer is that it enables us to do cross-app analysis, in which sometime when we run heuristic on account level, these activities can be legitimate, but when we look at the identity level perspective, usually is not. For example, user is logged into multiple accounts via Israel, while there is a specific account which the user is suddenly being logged in via Russia, via another country. So this is like very weird. And the second thing is that will enable us to build a baseline to remove a lot of noise, like I showed you before. Recap about knowledge graphs. So knowledge graph are graph. Graph usually add node like the circle or entities and edges, but in the particular case of knowledge graph, there are also relationship, like the edges themselves and as have meaningful, they are called relationship. So we can see like an head, relationship, and tail. For example, company located in specific city, and at the right side of the screen, like here, you can see like an example from the behind the scene of our knowledge graph taken from Neo4j. Knowledge graph representation learning is a type of machine learning process in which basically at the end, we want to generate representation for graph, for node, from relationship. This representation, like you see, are basically the embedding that we can then use for many type of analysis. A graph neural network are type of machine learning which know how to take as an input graph. And this is like a simple approach in which, for example, you want to take prediction of the red node. So the graph, like the graph convolution layer, basically aggregate all the information from all the neighbors. And at the end, being able to generate a vector of representation for the specific node, which allow you also to predict a specific label if you train this specific network as a classifier, for example. From knowledge graph, it looks the same, while this time you don't only embed nodes, you embed also the relationship, and you try embed and train the network in a way that you can run arithmetic operation on the specific vector. I will show you, this is an example for intuition why it can work and why it's worked well. So these are real examples. For example, you take the vector that represents Obama, you take the vector that represents the nationality, and you sum these two vectors and you get a vector of American. And you can see here also another example from word to vec. If you subtract men from king and add woman, you get the vector of queen. So this is our motivation, and this is what we do behind the scene in Reco. But in Reco, we apply temporal knowledge graph learning, in which the vector is being changed all the time. So every time we have a specific vector, for example, for each user, so let's call it VT, the identity observer time T. And if we want to have the baseline of the organization, the simple way to do it is just take an average of specific time of all the vector of all the employees in the company. Of course, you can do it for a team, for a group, for a department, for a site. and also for external domain. And then there are multiple approaches that we can use dynamically to look for major change. For example, we can see that the difference between a vector of a specific user in a specific time is much, much, much higher than the difference between the organizational baseline, how the organization has been changed at the same time. And we can also use knowledge graph representation learning, like I'm taking the vector of the specific user plus login, subtract the IP of the specific time. If it's very, very large, if like the distance is huge, I can see, oh, there is a problem. Like it doesn't make sense that Tal is currently being logged in, and I don't know, from Russia or something else. Another option is to use, many people are aware of the problem of link prediction, but there is also the problem of unlinked prediction. It means that I predict that there could not be a relation or a connection between the specific user and the specific account, or the specific user or the specific location. And this is example of this vector behind the scene, and we can see that when there is issue, like for example, here when I add the red circle, it's very far from the regular pattern. So it's captured like when something happens, it's much, much easier to see it in the embedded space than by looking at the audit logs. And these are the result in our some screenshots taken from our product based from the connection between different alerts at the same time and the identity consolidation. And this is the way that basically we map the MGM breach into a lot of policies, and there are many more, specifically in Okta, that basically cover all of the steps that are aware that were during the MGM result, and also some best practices offered by Okta themselves. So key takeaway: attacker cleverly insert them between user and IDP, start from a phishing attack and then made in the middle. It's hard to detect. Attacker reuse legitimate token, and due to the dynamic nature of current organization and hybrid warfare, the current heuristic and rule-based policy result with many false positive. Using AI technology can basically help detect SaaS hijacking and other sophisticated attack in near real time. Thank you.
Thanks a lot, Tal. That was really educative. Though, again, some of the slides obviously are much more complicated to understand. So if you are lacking some experience or understanding of how LLMs work or what is Gen AI behind the scenes, again, you can go read about it a bit, hear some podcasts about it, and then get back to the recording that, as mentioned before, will be provided to you on our Meetup website. So now to a few questions. Let's see. Okay, Josh asks, can the Reco platform? Okay, that's the question that was asked, that the author was asked, and they said that I think it would be better to answer during your session or after your session. So, can your platform basically detect anomalies and assist with detection of anomalies on sensitive data? So a user that is trying to do something to sensitive information, but in a different way that they usually do.
Yeah, so there is the usual way to do anomaly. For example, basically you track specific metrics on every user, like all the time, and then, like, for example, this user is usually downloading, let's say, 10 files per day, and now we have seen that suddenly the user download 100 files. So we do basically track all of this metric to basically allow our customer to be able to define their own policy and use like dynamic threshold and dynamic threshold that are basically adapted for every specific user based on the consolidation. But we also do it like in the embedding space, like I told you, basically being able to see, oh, there is a huge difference between the user or the specific action. Like the same way that I can embed the user, I can also embed each event, and I see, oh, there is a huge gap, and the result is basically also being able to capture all of this anomaly. But usually, most of the things, when we actually investigated these cases with our customer, we seen that this was used real events, and the false positive has been reduced dramatically.
Excellent. Another question is, can you provide visibility into attacks against the business processes, for example, HR, onboarding, offboarding, moving from between departments, financial business processes like accounts payable, things like this, sales, etc.
So, like I said, one of the ways also being able to map or build a baseline, not only for a specific user or the entire organization, but you can also build a baseline for the specific business process, and being able to see either a dramatic change or a specific identity that via communication or collaboration pattern started to interact with the specific business process, and we see that there is a huge difference. Like I show you in the graph, like there is a huge difference, and this is also one of the way that we use basically to map, and also we have a published pattern for this specific business processes that allow you to being able to detect, for example, user that had access to a data, although the user is not part of the business process that is related to this data. I hope that I answered this question.
So basically, just to try to summarize it in a different way, you are agnostic to the specific business process. So I don't need to first map how the business process looks like, because you can learn over time how it should look like. Then you find the abnormalities in the pattern, and you can immediately color them. In this case, not in a different color, but as you showed before, far away from the rest of the vector.
Yeah.
Excellent. And I assume that one also okay, so that's one interesting one. I assume it's not relevant. So is your focus is to provide visibility on attacks against SaaS apps that exploit vendor published vulnerabilities and to display the attack path and how to stop them? No, so in this case, obviously, it's not the case. Again, just I think that one is more relevant for IaaS and PaaS solutions, and those should be run by the SaaS provider itself. So as a SaaS provider, let's say you're Salesforce, you should have your own IaaS or PaaS a security layer, like Moshe mentioned before, the CSPM or CWP, in order to figure out if someone is trying to exploit a vendor published vulnerability. So that's more like an infrastructure and platform, less of a SaaS, because usually for SaaS, you hardly have non-vulnerabilities, or whatever you have is under the shared responsibility under the vendor side, not yours. Next one is, do you learn the normal behavior baseline and alert the platform use of high-risk activity in the SaaS apps of an organization? So yes, Joe, I think sorry for stealing your answer in this case, Tal. That's exactly what Tal was talking about the entire session. So that's how it works, basically. look for abnormalities, but instead of the need to study or the need to train it, it's automatically being trained.
And it's dynamic, like the threshold are dynamic and being changed all the time.
By the way, how much time it takes to actually learn it? I mean, do I need to run it for an hour, a day, a week?
Yeah, so last week when they published, so since the publish of ChatGPT, usually when people think about generative AI, they think about text, also about like a vision, like DALL-E, etc. But there is also fascinating field in knowledge graph that is called like generative AI or building a fundamental model for graph or for knowledge graph, and this is exactly what we basically try to do. So in order, so the inference, basically, you can do it all the time in no time, and you train the graph in a way that it learns to understand organization in a general way, and then like you don't need basically you train it all the time, but you don't need like like let's say 5 years ago you have actually to train the model all the time to study the specific like every single time. Now you can move a lot of the work for basically for the inference.
Hmm. So basically, it's a continuous training
Yeah,
plus a general training. So basically, you bring what you learn already from the world to any organization that is using it.
yeah, exactly.
Excellent. And last question, at least for now, by Michael. What is the improvement you were able to achieve in FP creation by using knowledge graph based on anomaly detection?
So we are talking about the false positive, let's say comparing a rule-based versus this dynamic policy. So it was dramatic. Like it was a gain of let's say around at least 90% like better reduce of the false positive in comparing to um, even comparing to dynamic threshold, regular dynamic threshold. So yeah.
Okay, so that's interesting. And Michael, hopefully that helped answering your question. Um, so unless there are more questions, again, feel free to also reach out to any of one of the panelists later on. That was today's meetup. Again, reminding you all that we have the contest and there is a swag, a cool swag. So either scan that QR code or you can find a link in the chat. Lior, if you can put it again in the chat, that would be awesome. And good luck for those that will win it. Maybe there is another question. No, just thanks for the answer. So that's amazing, and thanks just for participating and asking all those questions. And lastly, and before we send you all to your way, either to back home or to your bed or to start the day, like Ofer, for example. Thanks a lot. It was a pleasure. Hopefully, you learned a lot. Thanks, Ofer. Thanks, Moshe, and thanks, Tal, for those sessions. And thanks, Lior, for leading the meetup itself, the entire meetup group. Again, join us. The recording will be uploaded to that link. And stay tuned. We are already working on the next couple of meetups that are coming right away. I mean, just around the corner. And with that being said, have a good day, good night, wherever you are.
Very
Bye bye.
much.
Bye bye. Bye bye.